Hey there, AP Stats kids. Today we're looking at Chapter 10. We're going to do some confidence intervals and significance testing. But we will be looking at two sets of data and comparing it. This will be a quick one actually because I'm only going to do the two sections. And probably 3 problems. And I'll show you a little bit of every one. Also, I'm not sure if they'll actually put this one on the test this year. But let's find out. Alright, pause it, read it, try it. So we're trying to see if Obama's approval rating went up from 2009 to 2010, right? All right, so we're going to state, plan, do, conclude. State. We're going to say that we are looking. Our null hypothesis is that I'm going to do P09 is equal to P10, right? The alternative hypothesis is there convincing evidence that its approval rate changed. All right, so we're doing confidence interval. Oh, so I guess this is what I'm trying to find, but this is not the best way to do it. Where P09 is the 09 approval rating and P10 is the 2010 approval rating. Okay? Let's check conditions. So let's plan. Is it random? Yeah, it's random. It told us. Is it normal? AKA, we're looking at N times P, N1 times N09 times P09, N times 1 minus P0909, N times P 2020, and N times 1 minus P 2020 and 2020, or 2010, 2010. And yeah, those are all bigger than or equal to 10, right? And is it independent? Is 2,000 or 1,000 people less than 10% of the population? Yeah, so it's independent. Now let's do. This is all over the place. All right. We are going to do a 2-sample. We have 2 samples. A 2-sample proportion, 2-proportion sample confidence interval, right? And now segue to the calculator. Hey y'all, we're looking at 10.1, problem number 1. I'm going to do stat, test. This is a 2-proportion Z interval. All right, the first one, there's 1,024 people. Half said yeah, so half of 1,024 is 512. 0.53 of the other one said yeah, so 0.53 times that, 10,000 or 1,010 is 535. N1 and N2 are sample size. I already did this for you guys. Confidence level of 0.9. Yep. Calculate. Boom. That's our Z interval. We did a Z interval. Boom. And we're back. I got a confidence interval of negative 0.6 or 0.66 to 0.006 was my confidence interval. And now for conclude. All right, so now listen carefully. We are 90% confident that the interval from negative 0.066 to 0.006 captures the true change in proportion of U.S. adults who approved President Obama's job performance from August 2009 to September 2010. In context, because 0 is part of that confidence interval, it is plausible that there is no difference in the approval rating. So we do not have convincing evidence that the approval rating has changed because 0 was part of the interval. I hope you guys weren't listening to that super fast. All right, next one. Can you hear it? Can you hear it? Can you hear it? Can you hear it? I hope I got somebody with that. All right, so let's do this beast. All right. Read it, think about it, and do it. This one we're going to be doing a significant test. We're going to state P1 is hearing loss in 12, 13. Hearing loss in teenagers from 2012 to 2000, whatever. I think I might have done this differently on the calculator. We'll see what I did in the calculator. I'm going to do P2 is hearing loss in 88 through 94. My null hypothesis is going to be that P1 equals P2 because we're going to assume they're not the same. Or I mean, they are the same. My alternative hypothesis is that P1 is greater than P2. There should be more hearing loss than P1. Here, calculator, I think I did the opposite. So hopefully I didn't. We'll see. Let's look at my conditions. Plan. Is it random? Yes. Is n1 times p1 and n times 1 minus p and n2 times p and n2 times 1 minus p2 all bigger than 10? So AK, is it normal? Yes. Is 1,800 or 3,000 teenagers less than 10% of all the teenagers? So is it independent? Yes. Now let's do. This is going to be a 2 proportion Z test. And fade away to the calculator. All right, y'all, it's 10.1 number 2. I'm looking at hearing loss. Again, we're going to go stat. Now this time we are doing a 2 proportion Z test. So I'm going to go test. This is a 2 proportion Z test. Our X1. So I'm going to take my 0.15 times 3,000 to get that. And when I did that, I got 351 out of my 3,000. And then my X2, I'm going to take my 0.195 times 1,800, which when I did that, I got 450 out of 1,800. And we think P1 was our original. We think P1 is less than P2, right? No, I hit clear. Dang it, I hope it saved it. Please, it did. Calculate, and that's our stuff right there. We got Z is -1, 1.96. Our P is 0. All right, enjoy. And I'm back. I got Z is -11.96, and P was 0. It means 0% chance. Now for the conclude. All right, well, listen carefully. We're going to make a decision and conclude. So our p-value is pretty much 0, which is definitely less than 0.05, which was our significance for this one, because it didn't tell us any differently. So we're going to reject the null hypothesis. So how can we conclude? We have convincing evidence that the proportion of all teens with hearing loss has increased. Right? Now, can we blame that on headphones? No, because it wasn't an experiment. This was a study. A study can only show correlation, not causation. Okay? Could have been something else. All right. Last problem. Last one I may ever do for AP Stats. All right. Which plastic, this is 10-2 now. Which plastic bags hold more weight? So now we're looking at mean, not proportion. Everything's the same except for conditions. So let's try it. All right, state plan to conclude. All right, so state. We're going to do mean T as target bags. Oh my gosh, computer, not today. Target bags in grams. We're going to do mu. P is public bags in grams. Please be better than me. Write better. This is ridiculous. And I'll show you. And we're going to do... all right, hold on a second. Let's check our conditions. Let's plan. Is it SRS? Yes. Is it normal? Well, usually for mean, we're looking for is the more than 30, is n more than 30. This one's not. So we're going to have to plot it. And when we plot it, there are no outliers or skew, so it is normal. Is it independent? Yeah, because 10 bags is less than 10% of all the bags, right? Do. All right, for this one, we are going to do a 2 sample T interval, not V or not Z because it's mean, for mu T minus mu P. And fade away to the calculator. Hello all, we're looking at 10.2 number 1 between the bags. Here's the bags. All right, for this one first, you're going to go stat edit, and then you're going to put all target on one side and all publics on the other side, right? Someone already did that for me. Thank you. Go stat test. Now, because we're using mean, we are going to be using a 2 sample T interval, right? Enter. Look at that. We're going to use not stats, but data. Because we have all our data in our list. We have list 1, list 2, frequencies 1, confidence level is 99. Never pool it. Calculate. It's thinking. It's thinking. Boom. That easy, guys. That easy. Enjoy. And we're back with our interval. I got from negative 100.9 to 7,285. Oh, mama. So conclude. Listen carefully. Now we use 99%, so we are 99% confident that the interval from negative 101 to 7,285 grams captures the true difference in mean capacity for plastic grocery bags from Target and from Publix. So now, in context, since this interval has 0, it's plausible that there's no difference between the two means. We do not have convincing evidence that there's a difference in mean capacity. Thank you for everyone who watched it. I hope you all do well. I hope you have a great day.